I will talk today about volcanoes, the fiery breath of our living planet. It is one of the most primal forces on Earth, a spectacle of raw, untamed power that both terrifies and mesmerizes. For millennia, humanity has watched mountains of fire awaken, reshaping the land and rewriting history. But what is the source of this fury? Is it simply the Earth's destruction, or is it part of a deeper, more creative process? To know that, let us dive into the science and the story of volcanoes to understand why they happen and how they have made our world what it is today. To understand volcanoes, we must first journey to the center of the Earth. Our planet is not a solid, cold rock. It has a complex, layered structure. At the center is the inner core, a ball of solid iron and nickel under immense pressure. Surrounding it is the outer core, a seething layer of liquid metal whose movement generates Earth's magnetic field. But the true engine of volcanism lies in the next layer, the mantle. The mantle is not liquid, but solid rock so hot, over 1,000 degrees Celsius 1,832 degrees Fahrenheit, that it behaves like a plastic, slowly churning over millions of years because of the immense heat from the core. This heat creates slow-moving currents called convection cells. Now, add the final ingredient, the crust. Earth's crust is broken into a giant jigsaw puzzle of pieces called tectonic plates. These plates float on the ductile mantle below. So, volcanoes are primarily born at the boundaries where these plates meet. Divergent boundaries are where plates pull apart, the mantle rock rises to fill the gap, pressure drops, and it melts, forming magma that rises to create undersea ridges or continental rift valleys. At convergent boundaries, an oceanic plate slams into a continental plate, where the denser oceanic plate is forced downward in a process called subduction. As it sinks, water trapped in the rock lowers the melting point of the mantle above it, generating vast amounts of magma. This is the origin of the Ring of Fire. Some volcanoes, like in Hawaii, exist far from plate boundaries. These are thought to be fueled by mantle plumes, narrow, superheated columns of rock rising from deep within the mantle, punching through the moving crust above like a blowtorch. This molten rock, called magma when underground, is lighter than the surrounding solid rock. It gathers in vast chambers, building pressure until the Earth's crust can no longer hold it back. The result is an eruption. When it reaches the surface, it is called lava. Not all eruptions are the same. Their style depends on one key factor, the viscosity of the magma, which is controlled by its silica content and gas levels. Low silica magma is runny, like motor oil. Gases can easily escape, leading to gentle, effusive eruptions with rivers of lava. These are the shield volcanoes of Hawaii and Iceland. High silica magma is thick and sticky, like toothpaste. It traps volcanic gases, building up tremendous pressure. The result is a catastrophic explosive eruption. The magma is blasted into the air, shattering into tiny particles of ash and rock. These eruptions create the iconic, towering Plinian columns, named after Pliny the Elder, who died observing Vesuvius, and can form calderas, gigantic craters, when the emptied magma chamber collapses. The immediate impact of a major eruption is undeniably destructive. Pyroclastic flows, superheated avalanches of gas, ash, and rock that race down slopes at hundreds of kilometers per hour, incinerating everything in their path. These were the primary killers in Pompeii. Ashfall, blanketing regions in toxic, heavy ash, collapsing roofs, poisoning farmland, and halting air travel. Lahars are devastating mudflows of volcanic debris and water that can bury towns long after the eruption itself. What about climate change? Explosive eruptions can inject vast quantities of sulfur dioxide into the stratosphere, forming aerosols that reflect sunlight and cool the planet for years. The 1815 eruption of Mount Tambora led to the year without a summer and global famine. But out of this destruction comes life. Volcanic ash breaks down into incredibly fertile soil, which has supported civilizations for centuries. Volcanoes build new land, creating entire island chains like Hawaii and Japan. They are also a source of geothermal energy, providing clean, renewable power. The very continents we live on were built, piece by piece, by volcanic activity over billions of years. Volcanoes are more than just natural disasters. They are vital parts of our planet's life support system. They are the pressure release valve for Earth's internal heat, the creators of the air we breathe and the ground we walk on. They remind us that our world is not a static museum piece, but a dynamic, living, and breathing entity. The same forces that destroyed Pompeii built the islands of Hawaii and fertilized the plains that feed billions. They are a humbling testament to the power of the world we call home, a power that both gives and takes away. What volcanic event in history do you find most fascinating? Share your thoughts in the comments. If you want to continue exploring the power of our planet, check out our next video on the science of earthquakes. Do not forget to like, subscribe, and hit the bell for more deep dives. Thanks for watching.